So we had, it has lost my PowerPoint's content. So Chapter 7 talks about arrays. And what we had done is we had introduced ourselves to the concept of arrays. We created a little array called scores. We wrote a loop that would fill up the scores. And then we wrote something that would print out the list. I'm not sure why. And then we wrote a loop that would go through and calculate the sum of all the scores. And then we calculated the average. So we're going to do something similar today. We're going to ask the user how many hours we work each day. So we need an array that'll hold in like 7 values. We have 7 days. But we're going to use the concept of parallel arrays. A parallel array is when you have 2 or more arrays where the pieces of data are linked by their index number. So we might have an array called day of week, and we might have an array called hours worked. And day of week, Monday, we worked 10 hours. Tuesday, we worked 1 hour. Wednesday, we worked 3 hours. Thursday, we took the day off, and so on. So this is day of week 0. This is hourly worked 0. This is day of week 1. Hours worked 1. Day of week 2. Hours worked 2. Just pretend there's an HW in front of each one of these. And pretend that there's a DOW in front of each one of these. So you get the idea? The hours worked is 10. The day was Monday. And these things are linked by their index number. So they're called parallel arrays. They should have the same number of elements. If you have 7 days in a week, you're going to have 7 hourly worked. If you have 31 days in a month, then you ought to have 31 hours worked or whatever. So let's create a new file. New project. I'm going to get my boilerplate in there. We may also be using strings. I'm pretty sure we are, so I'm going to also do # include strings without an S. Okay, so what is this going to do? Let's add a comment up here. Well, you know, my name, Jeff Thompson, March 27. Hours worked calculator keeps track of hours worked each day of the week by using parallel arrays. So I'm going to go ahead, and you don't have to put it, but I'm going to define what a parallel array is. Parallel arrays are 2 or more arrays where the data is linked thematically or conceptually by the index values. So let's define an array of days of the week. I may just call it days. String days. Now I could do this. I could put in a 7 there and then I could fill them all in. Kind of stop typing for a second. I could do days 0 is equal to Monday. Days 1 is equal to Tuesday. But I'd rather use an initializer list so I don't have to go to all that trouble. So instead I'm going to make it look like this. String days is equal to, and then I use some curly braces, Monday, Tuesday, and I'm putting the names in with quotes, and then I'm separating each string with a comma. Wednesday, Thursday, and I've kind of run out of room, so I'm going to go down to the next line. Friday, Saturday, Sunday. I forgot my colon, that's why I'm getting an error down here on the system pause. Now we need an array of hours of the same length. Now we could count how many items are in days. Or we could just hard code it to 7. We're pretty much sure that everywhere they speak English there are 7 days in a week. Let's go ahead and do the trick of getting the length based on the size of the array divided by the size of the elements in the array. So int num days is equal, and this is overkill because obviously there's going to be 7 days in a week, but let's do it anyways. The size of the array, days array, divided by the size of a string. And let's just print that out. Make sure we're on the right track. Cout num days equals arrow arrow num days arrow arrow ENDL. Number of days is 7. Okay. We have successfully counted the days in a week. I'm happy. Why do we do that? Just to show that you can calculate the length of the array. In some cases. You can as long as you're in the same context that the array has been declared, in the same scope that the array has been declared. If you try to pass that array to a function, you won't be able to count it like this. But it works here. So let's allocate. We don't really need that cout anymore. I'm convinced it works, so I'm going to comment it out. But we need an array of doubles, or ints if we assume that they can only work whole number of hours, but let's use doubles. Double hours num days. Alrighty, all of that was for naught. It's saying that the expression must have a constant value. No, it wasn't all for naught. There we go. Okay. I had to, in order to get this to work, I had to put the word const in front of this int num days. That's because the compiler is expecting us to only use constant numbers or numeric literals for the size of the array. All right, that's great and all that, but we need to zero out that array. Right now, if we printed the array, it would be full of random data. I showed you all that last time. This language does not zero out your arrays, unlike some languages like Java. So let's write a for loop for int I is equal to 0. I is less than num days. Okay, and I'm separating these by semicolons. We could also use a while loop. I've been needing to talk to you all about for loops, so I'm throwing this in. I plus plus. I think I did that last. Did I use a for loop on Wednesday?
You used a while loop.
I used a while loop. Fine. Nah, let's grit our teeth and go with it, and then we'll talk about for loops after we do this. A for loop is just a while loop with a cleaner syntax, to be honest. You get to specify the starting position. You get to specify the conditional expression on which it repeats, and then you get to specify the update. So instead of taking 3 lines where you initialize a counter and then you have a while statement and then you have an I++ at the end, you get to define it all at once. So that's what a for loop is. It's a much cleaner syntax for writing loops. So I'm going to introduce it to you and then we're going to go back and talk about it. But anyways, hours subscript I, hours square brace I is equal to 0. We're just going to wipe that array out. What I mean by that is we're assigning 0 to every element in the array. We're clearing it out to fill up with data later. Now we need another loop that will go and ask the user for how many hours they worked each day. So again, it's going to be that for statement. I could just copy and paste it. That'd be the fastest thing. For int I is equal to 0, I is less than num days, I++. Let's ask the user, cout hours worked on, and let's print the month out, the day out. So quote, close quote, arrow, arrow, days, I. Followed by maybe a question mark and a space. We need to read that in to a double, and then we'll store it in the array. So double, I don't know, value is equal to, no Java. Double value, CIN into the value, and then assign that to the array. Hours I is equal to the value. All right. At that point, go ahead and run it just to make sure that we don't have any syntax errors. Sure, it doesn't do anything after you collect the data, so don't spend a lot of time entering important data. But go ahead and run it. It says hours worked on Monday, type in a number. Hours worked on Tuesday, type in a number, and so on. Just do all that. Make sure it works. So again, it's just going to be a copy of that for loop state syntax. I'm just going to copy it this time rather than type it in again. And I'm going to cout days subscript, in other words, square braces, I subscript ENDL. That's just going to print the days of the week. That's not going to be too marvelous. So just enter 7 random numbers, and it prints Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. We don't just want it to say the day, though. We also want it to say the hours. And we really want them to, well, I think we can get away in this case without setting a width. But we might wind up using I/O manipulators in order to make these things look a little bit better. Anyways, along with days, we want to output maybe a tab to separate them, /T, followed by hours at I. Hours subscript I. All right, so that's what it did for me when I ran it. Now, what would be the obvious extension to this, based on what we've done and all the other times when we've collected numbers like this?
Total?
Yeah, let's get the total. I want y'all to take a stab for a few minutes at calculating the sum of all these hours yourself. Declare a double called sum, and then use a loop, adding each value to it. And of course, I'll give you the answer in a minute, but I want y'all to take a stab at it. So start it off with double sum is equal to 0, and then use a for loop to add all the values of the hours array to that loop. Be right back. Who's got a working sum calculator? Square, yeah, just like that, and sum plus equals hours subscript I, square brackets I. So hours, square braces I. Yep. You were going to divide like you were going to calculate the average, but we didn't need to do that. We could do it underneath it. So, since we have our sum variable here, for sum int I is equal to 0, I is less than num days, I plus plus, sum plus equals, hours, subscript I. And since we're not using a while loop, I don't need to do I plus plus. It's already taken care of right here. Then I could print it out. C out total hours worked equals sum arrow arrow E and DL. All right, I think mine's working. So somebody tell me, I think there is, but if you're already familiar with C++, is there a for each syntax for C++ like there is in C# and for Java? For each in C++. Nah, we're not going to do that. Let's give it a shot. Maybe that'll work. For int I colon in hours. Nope, it's a double, sorry. For double D in the hours list. C out D. This is just an experiment. I should not be jumping ahead like this, but it's a different kind of syntax. In the languages that support it, it's called for each. C# actually uses the word each there, for dash each. It means for every double that is stored in the hours array, print it out. And you can see that that syntax is considerably simpler than doing it that way. So when a language does support for each, it's pretty cool. Run it, see if that works. One, two, three, 4, 5, 6, 7 hours worked. It did work. Neato keen. That's not the real point of the assignment. I'm going to comment that out. So the homework assignment based on this is going to be very similar. It's just going to have a few extra things which we aren't going to do today, but which we will talk about on Wednesday. Write an assignment, not an assignment, write a program that prompts the user for the rainfall for each month of the year. January, February, March, etc., all the way up to December. Then calculate the sum of the array, the average of the array, which month has the most rainfall, and which month has the least rainfall. You already know enough to do this part. So if you're going to go home to do it tomorrow or tonight or whatever, you could do this part lickety-split, because it's very similar to what we've already done, right? Write an program. Let's use good English. Write a program. But we will learn how to run through it and find, the one with the highest and the one with the lowest. Anybody need help finishing the in-class assignment? I tabbed away from it. We all good? All right, just a sec. Make that a constant. C-O-N-S-T. Space. Okay, good. When you declare an array, as we did up at the top, you either don't specify a size at all because you're giving it an initialization list like that and it figures out that it's supposed to be 7 or whatever. Or you specify the size. On our assignment last Wednesday, I think we may have hard-coded it, like to 10 or something. So we just put in a literal value. And a literal value is a constant, so that worked. But here we wanted to use a variable to declare how many elements are in our array, our parallel array. So we calculated it using this method, size of the array divided by the size of the elements. But then we had to make it a constant before the language would accept it as the argument to that creator. Is it working now? Okay, just a sec. So just as a review, if we had this array, and we want to get a hold of this element, what's the index number for that element? 0. So what's the index element of that one?
4.
Correct. It's length of the array minus 1. So it's 4. What happens if you go past the end of the array? You'll probably get a crash. At the very least, it's accessing data that is not valid data. Some languages will just shut it down right there. It'll blow up instantly. C++ is not one of those languages, but you may crash your program, or the debug version of it will warn you after it's done that some dirty deeds were done. So using a loop to step through an array. Here's a for. Let's break down what the for loop is. If we have a while loop, it looks something like this. We have to declare our counter. We have to initialize our counter. Then we have to have a condition. While I is less than 10. So that's our condition. Then we do something, whatever that something is, even if it's just printing out I. And then we have to increment I. That's your classic while loop using a counter. Now you can use whiles for other cases too that don't involve counters. But that is an incredibly common loop to write, is one that counts through things. A for loop does this. You define the for loop, you put some parentheses, and then for the first part you put your initialization separated by a comma, a semicolon, then you have your condition, and then a semicolon, and then your increment. That's the syntax of it. Now obviously that's not good syntax, but we'll go ahead and fill those things. For int I is equal to 0, I is less than 10, I++, and let's see out I. So you see how we effectively did, ignoring the braces, in 2 lines of code, what took this one to do 4 lines of code. So it's a more concise syntax. That's one of the things I like about it. The other is that when I'm writing while loops, I always forget to add my increment, and so I always write infinite loops until I remember to go back and I add the I++. And it's
You have to go back and, like, if you're doing another while loop that uses I, you have to put I equals 0 again.
right. You have to reinitialize I back to 0 each time if you want to use that variable name over and over and over. So a for loop keeps this counter local to the loop itself. I is only available in that scope, which is kind of nice. Here we had to define our variable outside the scope of the loop. Here it's available only inside the scope of the loop, and so it disappears when it gets here, which is nice. So this could be anything. It doesn't have to be 0. This could be anything. It doesn't have to be less than 10. This could be anything. You could write a loop that counted backwards. For int x is equal to 10. X is greater than or equal to 1. X minus minus. That would print out all the numbers from 10 down to 1. What is this one going to print, really? It's going to start counting at 0, and then it's going to stop at what number? It's actually going to count up to 9, because once I reaches 10, that's it. It falls out of the loop. If I wanted to include 10 in it, I would make it less than or equal to. You can leave off any of these things separated by semicolons if you wanted to. And there you're kind of perverting the syntax a little bit, but you could do so. If I was already declared somewhere else, you could just leave that blank. I is less than 10. I++. Do you do that often? Well, I don't, but you could. You can leave the middle part out too. But if you leave the middle part out, you have to use a break statement or a return to get out of the loop. You could leave the update out. You could leave all 3 of them out, which is absolutely ridiculous. In that case, this is now the same thing as writing while true. So those things are optional, but you may as well use them all unless you come up with a need to not, because you always need to initialize your counter. Well, not always, but usually. If what do you use these loops for? If you are going through a range of values, you know in advance the values that you're going through. Use a for loop. There's 2 other kinds of loops. There are while loops, and then there are do loops. Do loops look like this. Int x is equal to 0. Do something. Let's output x again. While x is less than 10. Now this looks very, very similar to our while loop. I'm going to rewrite this as a while loop. But it behaves very different in one key aspect. X is equal to 0. I'm going to reset x equal to 0. While x is less than 10, print out x. The difference is, I mean, these would both print out the numbers 0 through 9. So they seem equivalent. The difference is that here the condition is checked first. It wouldn't even go into this loop if x was set to something that was not less than 10. If I change this to x is equal to 100, nothing's going to happen. It won't print anything out. X is equal to 100, while x is less than 10. Is x less than 10? No, because it's 100, so it skips all that. But if I change this one to 100, Let's follow the logic. X is equal to 100. Do. It prints 100 out. Oh, and by the way, these are infinite loops because I forgot the increment. There we go. X plus plus. Got to do it there. And got to do it here. So anyways, this one, since the condition came first before the operations, it never even went inside it. Just like this was an if statement. If x is less than 10, do this. While x is less than 10, do this. So wouldn't do it. Here, x is equal to 100, do this. Go ahead and print it out, add 1 to it, and then check our condition. Well, is x less than 10? No, it's 101, so it falls out of the loop at that point. So this wouldn't print anything, and this would print something. This is called a pretest loop. The test happens before the body of the code that's to be performed. So while loops are pretest. Meaning that the test, the condition, is checked before the body of the loop. And you know what I mean by body. It's the stuff between curly braces. Do loops are post-test. Meaning that the test, the condition, is checked after the body of the loop. Sometimes that gives you the same results. Sometimes it does not. Here's a case of where it does not. That wouldn't print anything, and this would print the number 100. After this code was done, x would equal 101. After this was done, x would still equal 100. So there are some material, there are tangible differences in the way the code works if the starting point is not a valid one for the loop. So let's go back and modify these rules. Guidelines for suggesting what kind of loop to use. If you're going through a range of values, if you know in advance the values you're stepping through, like if you have an array that's already defined, or you know that you want to go 1 to 100 or 99 to 1 or whatever, use a for loop, just because the syntax is clean and easy to write. If you need to perform the body of the loop at least one time, no matter what, use a do loop. Otherwise, if neither one of those two other cases are true, just fall back to a while loop. Now, honestly, there is no difference in what you can achieve with a while loop that there is with what you can achieve with a for loop. It's just a cleaner syntax. So you could always just use a while loop unless you need to use a do loop. But as you program, you're going to see for loops in every language you get a hold of, and the syntax for them is cleaner. You may as well learn them and love them. I call it the one loop to rule them all, and in the darkness bind them. So here we go. The initializer, the condition, and the update. If this initializes wrong, it's not going to go into it. If we started x off at 100 here, and we were counting while, if we set I equal to 100, but we were counting to while I was less than 10, it wouldn't go into it. Because a for loop is a pretest loop, just like a while loop. They are the same thing, except the syntax is nicer. So go back to our code, and let's just add a couple of loops. And heck, let's add them up to the top. Let's write a loop that counts from 20 to 30. Let's write a loop that counts from 100 to 1. Nah, that's too big a range. From 10 to 1. And then write a loop that counts from 10 to 100 by 5s. And these numbers are inclusive. I want it to display 20 and 30. So I'm going to tack on the word inclusive. You know what that means? It means that both the lower and the upper range need to be part of the output. Alrighty. So, I'm just going to use I because it's my favorite counter, I and X, for int I is equal to 20. That's my starting point. And what syntax should I use to get it up to 30? I is, keep repeating while I is what?
Less than or equal to 30?
Less than or equal to 30. That makes more sense to me than making it less than 31. Both would work. I plus plus. Now let's see out that number, followed by a space. And then at the end of it, let's see out an ENDL. Why? So that it'll put all the numbers on one line. That's the only reason I did it that way. If you put an ENDL inside the body of the loop, of course, it would print each number on its own line. So run that, see if it works. Oh, I don't need to enter the data. That 20, 21, all the way to 30, yeah, that looks good. Okay. Try the next one on your own. I demonstrated it in the notes, but go ahead and make I start at 10, keep running while it's greater than or equal to 1, but your update better not be plus plus, it should be minus minus. All right, I'm going to do it up here as well. So if you're stuck, you can copy. And then if you've done that second one, take a stab at doing the third one. What's your update going to be? It's not going to be I plus plus. What could you do to pop it up by 5 each time? I plus equals 5. Right, I plus equals 5 would do it. All right, so that's working. 20 to 30 and then 10 down to 1. So our last loop, for int I is equal, I want it to start at 10. Keep running while it's less than or equal to 100, but I want it to go up by 5 each time. So I plus equals 5. Looked like that worked. I'm trying something. Don't bother typing this. Okay, another way in which you could mutate the syntax of the for loop is you could initialize more than one variable in the initializing. And this is not possible in some languages like Java that borrow this syntax. I never do this, but you could. This is just a demonstration of something to be aware of. For int x is equal to 0, y is equal to 100. Keep running as long as x is less than or equal to 10. And then for our oh, I forgot to put I and t in front of there. I'm going to break this into separate lines to make it easier to read, or harder to read, depending on your opinion.
I don't think you need a semicolon between.
I put a that's a comma. That's my mistake. Cout x followed by a space followed by a y followed by an ENDL. I'm going to go ahead and put this all back on one line now. So you see what it's doing? It declared 2 counters, not just one. And every time it increments both x and y. Well, y gets decremented since it's got minus minus. Take out that second word, int. All right, it worked. You see how x is going up in our output while y is going down? We declared x, we set it equal to 0, y we set equal to 100. And then each time we incremented, or each time we updated, x went up by 1 and y went down by 1. Like I said, I can't think of a good use for declaring more than one counter like that, but you could. And this condition could be as simple or as complex as you need. It could have ands in it and ors. Your update could call a function rather than just do x plus plus. You better have a way of getting out of the loop, you know, if that's the case, a break statement or something. But you can mutate the syntax of this a lot. I'm not going to be demonstrating any of that in this class. I'm going to use pretty much a strict and straightforward like this from now on. I just want this you to lodge in your brain. If you see somebody leaving parts out of the for loop syntax or tacking on multiple things like this separated by commas, that's what they're doing. They're taking advantage of the syntax to do things more than just a simple counter. So that's an example of that. All right, we are about done for the day. All of the examples that we will see that use arrays will use for loops, just because it's concise. Here they're declaring an array called array size, numbers. They use this constant as the size, and then when they count through it, they check to see while count is less than array size. So if array size is 5, this will print out elements 0, 1, 2, 3, and 4. Well, let's create a Dropbox. And I need to also create one for the homework, wherever I put it. No, I can't find it. Did I not write up the description of what it did? I'm sure I did. Oh, there it is. Okay. So this will be Dropbox I, which is arrays and for loops. Excuse me, parallel arrays. All right, we'll make the rainfall due next week. Sunday night. If you were going to work on it tonight or tomorrow night, you ought to be able to do everything except for maybe the calculate the highest and the lowest rainfalls.